to the speaker. And with that, we are ready to move on to the final presentation of this session, which is another reproducibility work. So the work is entitled Reproducibility of LLM-based Recommender System, the case study of P5 paradigm by Marco.
Thank you so much. Hello, everybody. I'm Marco Polignano from the University of Bari, and I'm here today to introduce our latest work, Reproducibility of LLM-based Recommender Systems, the case study of P5 paradigm. And in this work also collaborate our master student, Antonio Silletti, which is now in IBM. So let's start from the introduction. So the starting thing that I want to tell you, all of you, that right now we are in a crisis of reproducibility because we are always more facing new algorithms in recommender systems that are using deep learning, that are using large language models that has a lot of problems with reproducibility. If you try to run also the same code twice with slight differences in libraries versions, for example, you can obtain completely different final results. So it's something that we have to take care, and we have to find some, we can say, solution, or at least try to mitigate this kind of problem. So in this specific work, what we have decided to do is to try to inspect and try to reproduce this very famous foundational work. The work is Recommendation as Language Processing, a Unified Pre-training Personalized Prompt, and Predict Paradigm P5. This work has been introduced here in the RecSys conference in 2022 and is considered as one of the most important contributions to recommender systems that use as backbone large language models. And we investigated this work, and then we tried to find a possible solution for mitigating somehow some of the issues that we have found. Let's start from the P5 model, just to introduce it to who doesn't know how it works. P5 model is a shared framework. It uses as a backbone the encoder-decoder T5 large language model, and then it is fine-tuned on different tasks about recommender systems with a single loss a single loss to optimize through the learning process. Moreover, the paper also proposed different strategies of personalization, one of them using some specific tokens for IDs of items and users, and another one using a wall embedding to be learned during the training strategy that can somehow apport this contribution through personalization. In a big picture, you have a model like this one with this P5 model in the middle and different sub-recommendation tasks like sequential recommendation, rating prediction, explanation generation, review summarization, and direct recommendation. Each of these tasks is provided as input for the fine-tuning approach proposed in the paper, and then for each task we have a specific output that is produced by the model. And in order to try to completely replicate the paper and the model that has been proposed here, we reuse exactly the same dataset proposed into the original paper, which is the Amazon toy dataset, the famous one released originally by Macaulay. And we reuse exactly the same splitting protocol proposed by the authors, and in particular the one that has been used is the leave one out. It means that we use the whole history of the user for training somehow the model, except the last item, which is our objective, our goal, something that we want to obtain at the end by the model. We replicate exactly we reuse exactly the same code released by the authors, and what we observe are results that are slightly different from the original ones. Sometimes the results that we obtained were better, sometimes bad, but the point is that at the end the results were not very close to the original. And the takeaway that we had from this first experiment was that very different reproduced results has been observed during this run. And in particular, we also tried to run our we can say run twice on 2 different machines in order to ensure repeatability of the results that we obtained. And what we obtained was consistent between the 2 runs. And at the end, what we somehow observed was that this kind of reproducibility is still a very big problem with this kind of architecture. So in order to mitigate the problem, we went through a second experiment. In this experiment, we tried to mitigate the problem by proposing a new framework. The framework is named like LLM. This framework ensured the full pipeline of recommendation in a replicability way. So we can use different backbones, so we can train over different tasks our model, over different data sets, evaluate the results over different metrics, and then we can rerun this everywhere without any kind of problem, also thanks to the thing that it is embedded into a Docker image. So the results that we obtained also with this second experiments were again different from the original results of the paper, but they somehow were more close to the original one. And we have also replicated the personalization strategy that was proposed in the original paper, and then we observed that the strategy more or less is quite good, it works well, and then we obtain quite good results. Finally, as a third experiment, in order to check if our framework was working well and correctly, also on other backbones that were not the original T5 model of the paper, we tried to extend somehow the original approach by proposing other 2 different backbones. We just use a very simple GPT-2 model and a FLAN T5 model, big and large. We also tried to improve a little bit the prompts that were originally used for fine-tuning the original model, going also to add more side info or trying to change a little bit how the prompt was formulated for training the model. What we obtained at the end was that the results, the final results obtained through this pipeline were quite better than the original, as expected, because we use as backbone a better model than the original T5. In particular, we can observe that FLAN T5 works quite well, but that's not the point. The point is that there is a large space for improvement in this kind of direction for recommendation. And for this reason, what we would like to do shortly in the short future is to try to extend and work a little bit more on the framework, trying to ensure the compatibility of our reproducibility framework with more backbones architectures through the use, for example, of the eigenphase transformer library, and try also to include novel strategies for instruction tuning and fine-tuning, for example, those based on LoRa. So that's what we have done, what we have proposed. So thank you so much, and I'm hoping to answer to any question.
Okay, thank you very much, Marco, about the work. So we have a few questions, and I think all of these questions are interesting because somehow they are pointing to what is the root of these inconsistencies that we are seeing with LLMs. So I'm going to read them for you. The first question says, don't you think that the replicability issue points out that the results of the paper are just by chance and not showing an interesting good property of the LLMs? I mean, only papers with good results tend to be published. Um, so this
Yeah,
is
okay. So I cannot be sure or just assert that the original results are by chance. That was not the point of our reproducibility work. The point was just to show you that this kind of black box models have a lot of problems during the reproducibility. Because, for example, if you run the same code with over one machine with a specific GPU, and then you change and go on another machine with another GPU, the internal numerical representation of weights is different. Also, how these weights are somehow approximated internally into the memory of the machine is different, so you will obtain slightly different results. So the important thing is that somehow when we want to obtain the original results, we have to reproduce everything: machine, GPU, libraries, parameters, configuration, split of data, and protocol for evaluation.
okay. Thank you very much. Let me ask one last question, which is a bit more high level, and it's also interesting to know your insight about. In your opinion, what is the root cause for inconsistency between the published result and the reproducibility result?
Yeah, as I said before, probably one of the most impacting factor was the different hardware that we use at the end, and for sure some slightly different versions of the libraries, because some of them were not more compatible with new Python versions, so we were forced to change them a little bit, and probably this is the most important factor that somehow affected the results.
All right. Yes, thank you very much. So there are other questions. Please feel free to reach out to Marco during the coffee break. So with that, we conclude session 16 of RecSys 2024. We're going to have a 50-minute break, and I think we will come back for the final session of RecSys. So thank you very much for your attention.